Welcome back. This video will have two fairly big examples. Examples of composing two functions. I wanted to remind you what composition means. We're going to compose capital F with capital G and create a new function where this function G is the input of function F. This first statement is read f of g of x, and this right-hand side of the equal sign literally says f of g of x. If you want to pause the video and write down these two functions with their domains, you could do that now. Capital F is going to be the rational function 1 over the difference x minus 3. And we can see that the domain for f must exclude 3. And the second function will be capital G, the reciprocal of the sum x plus 2, or 1 over x plus 2. And we can see that x cannot be negative 2 for function G. First, I want to remind us how we determine the domain of a composition function. Okay. If you look at a definition in a textbook, the domain of this composition, f composed with g, is a set of values of x that satisfy two things. The set of values of x where x is first in the domain of g, and second, it's just the set of values of x such that g of x will end up being in the domain of f. So each value x in the domain has to satisfy two things. X has to be in the domain of g, and when you plug in x to g, g of x has to be in the domain of f. Just more specifically, if we had some function that excluded the value x equals 3, and I'm saying x could not be 3, then the domain of f composed with g would exclude values of x that would make g of x equals 3. A person would need to set up this equation and go backwards and find that value of x. And we're going to do that in the next example, or in the first example. Okay. So for our first example, I'm going to ask us to create the function f composed with g with those two functions I had posted earlier. I'll lay those down right here. Okay. The outputs of the function f composed with g would look like so. And by definition, we're going to take big function f and use function g of x as the input. And if we look how f is defined, we have 1 over this difference. If f is applied to x, it's 1 over the difference x minus 3. But f is being applied to g of x, so it's 1 over g of x minus 3. And g of x is defined as the ratio 1 over x plus 2. Don't forget the subtract 3. And here in line 3, we have an answer. It's not a simplified answer, but this is indeed a function, the correct function. Okay. Now you might want to pause here and think about how you can simplify line 3. I'll continue on. I need to remind us that we need a common denominator when we are subtracting two ratios. So I'm going to leave that 1 in the numerator. Looks like my common denominator is going to be x plus 2. So I'm going to rewrite the integer 3 as 3 over 1. And since I need to multiply the denominator by x plus 2, I will also multiply the numerator by x plus 2. Result: 1 over this difference. The difference has a denominator x plus 2. And I'm going to subtract across the top. So I have 1 minus 3 times x, and I also am subtracting 3 times 2, which is subtracting 6. If you want to look again, I distributed the subtraction. I subtracted 3 times x, and then I subtracted 3 times the 2. Okay. And if we collect like terms, looks like I get a negative 3x minus 5 in the middle over x plus 2. Pull the paper up so that you can see. And 1 divided by this fraction is the same thing as 1 times the reciprocal of that fraction, which will give us a final answer of the sum x plus 2 over negative 3x minus 5. Now, so this is one way to write our final answer. You might see in the back of a book someone else might write x plus 2 on top, and then they might factor out a negative 1 from the bottom, leaving 3x plus 5. But either way, this ratio is equivalent to this one. And then I'd like us to think about what the domain of the composition function is. Okay. Laying back down these functions we started with. The domain of the composition f composed with g, the values of x have to lie in the domain of g, so x could not be negative 2 to begin with. And then we want to make sure we don't plug in a value of x that makes f of x undefined. So we set g of x equal to 3 and solve. Okay, and I will let you do that at home. Maybe put 3 over 1 and solve the proportion. But that's you're gonna get another value of x that we're gonna have to exclude, and that is gonna have to be negative 5/3. You might want to pause it this time and think about this red part here. The domain of our new composition function is all real values except negative 2 and negative 5/3. Okay, again, you may want to pause it, look at that. But I'm going to pose one more composition problem for you. Composition is not commutative. So if we create G composed with f, those outputs are going to look as such. And to do the calculations, g is on the outside, capital F of x becomes the input. Okay. And if we want to think about domain before we even begin, we have to think about the domain of f, and we look back, x cannot be 3. And then, if you look back at g, the inputs cannot be 2 or negative 2. So that implies that our input f of x cannot equal negative 2. So I'm going to let that remain there. We'll do our calculations, and then we'll come back and figure out the domain again. So g of f of x, what does g say to do? G is the reciprocal of this sum. G is 1 over the input plus 2. But our input is the function 1 over x minus 3. Get a common denominator. The common denominator will be x minus 3. The numerator will end up being 1 plus 2 times x minus 3. Do you know why? You may want to record some extra steps here. You might want to record how one thinks about this integer as 2 over 1, and then multiplies the top and the bottom by x minus 3 to rename. Okay. Well, if we distribute the 2, we get 2x minus 6. So we'll end up with 1 plus 2x minus 6 all over x minus 3. And as we saw last time, 1 divided by this fraction is the same thing as 1 times its reciprocal. And I didn't simplify this to begin with, but it looks like 1 minus 6 would be negative 5. Okay. Now here in black, it looks like x cannot be 2.5. We're going to have to restrict x so that x is not 2.5 and x is not 5 over 2. Okay. Here's our answer. Let's go back to the idea of domain. The domain of our new function, g composed with f, is all real numbers except x cannot be 3, because if x were 3, it would make f of x undefined. And f of x cannot be negative 2. If you take a moment and solve this equation, you will see that that implies that x does not equal 5 halves, or 2.5. The domain of our composition function excludes both 3 and 5 halves. Okay, thank you for your attention.